Hello everybody, how are you? Today I wanted to show how to calculate zonal statistics in ArcGIS and the remote sensing software. For example, if you wanted to the descriptive statistics of environmental covariety, for example, in the prediction of soil depths, like the elevation, slope, hillshade, and aspect, up to the enhanced vegetation index from source of demo or SRTM DEM for the minimum, maximum, mean, standard deviation, and the coefficient of variation or CV. So how to calculate this descriptive statistics in ArcGIS for the raster data file. Raster data file in ArcGIS. Go to open ArcGIS. Yeah, here is the ArcGIS. We can call the first step shapefile of our study area. So for example, we can, if you wanted to total catchment or total catchment, for example, if you can take the total catchment, here is the total catchment, okay. Here is the total catchment, and later we can call shapefile, okay. Shapefile, we can open shapefile. Example, shapefile is Lake Aramaya with a shade, yeah. So here, good, yeah. Here is the shapefile, and here is the total catchment. How to calculate the zonal statistics. So we can click on the ArcTool box and go to the spatial analysis tool. Spatial analysis tool. Spatial analysis tool. We can wait. Okay, it can wait. So what we wanted to or gonna to calculate is about the mean, maximum, mean, standard deviation, and the coefficient of variation. Coefficient of variation. Coefficient of variation. So we can wait. We can wait until it's finished. So again, also based on your interest, you may also calculate about the skewness and the kurtosis, again, median, and the square of standard error of the mean. Again, also we wanted to calculate standard error of the mean. So here, good. So go to spatial analysis tool, zonal, and we can click on zonal statistics at a table. Not zonal statistics. Here is the zonal statistics at a table. Just can click. So we can drop here shapefile. My shapefile is you see here is a Lake Arama watershed, and also here is ID or FID. So we can take by default is ID, and the input file is the total catchment area, and the output file that we can say here is the catchment zonal statistics, then save, then so you see here is the, could you find the mean, maximum, minimum, range, standard deviation, sum? I wanted to calculate all. So just okay. We can wait until the zone. Yeah, good. Here is, our calculation is right. We can check here, open attribute, okay, yeah. You see here is what, here is the minimum is 0, maximum is 0.018, it is the range, mean, standard deviation, and the sum. So how to rejoin here into a watershed, So we can look, we can click on Lake Arama watershed shapefile and join attribute. So here is the choose in the field, if you remember, is ID, and also here is the catchment zonal statics. Good. Zonal statics, catchment of the zonal statics. So we are going to okay. We are going to okay. Look. So we can check. Open attribute. You see here is a minimum and the maximum, range, mean, standard deviation, and the sum. So we can simply take these values into here. You see, for example, when we can minimize, for example, what about the total catchment? Total catchment area. Total catchment area. Here is the total catchment area. The minimum is what? 0, and the maximum is total catchment 0.00, maximum 0.018, and mean is 0.001, and about the standard deviation is 0.00068, and here 60.008. So CV is, CV is standard deviation over mean times 100. So here is what we call about the zonal statics in ArcGIS and the remote sensing software. So you see here is very important for the descriptive statics of environmental covariety used for the prediction of soil depth. Again, another such like parameters. So here is very useful today research YouTube or video. So thank you for your attention.